Hi, I'm Jace from Itri, Taiwan. Today I'm going to talk about the container-based NFVI with performance analysis and tuning for mobile edge private networks. We all know about network function virtualization, right? In short, NFV decouples the network functions from proprietary hardware and runs them on a software platform. We can now easily deploy virtualized network functions on general-purpose servers. Also, Cisco estimated that more than 73% of the traffic will come from within the data center, and most of it will be VN-to-VN traffic. So we have more and more network traffic in virtual environments right now. Although NFV brings flexibility, it also provides us with new challenges. For example, monitoring network traffic in a virtual environment is more complex than in dedicated hardware. Meanwhile, it's hard to monitor the network traffic without dealing with performance overhead in a virtual environment. For a traditional switch or router, you can just mirror a physical port to monitor traffic. But in a virtual environment, this consumes CPU resources and creates performance overhead. Another problem is that in the virtual environment, we have so many stacks. We have hardware OS, virtual switch, container runtime, or hypervisor. Any misconfiguration performed on these components can result in performance bottlenecks. In 2017, Intel reached out to us and created an Nfv Performance Lab for the Asia Pacific region. Our goal is to help ODM OEMs to do the NFV performance characterization. Most of the vendors have no or little idea about choosing the best CPU for their products. Our performance lab conducts NFVI and VNF performance tests to find out the bottlenecks. To be more specific, we can provide suggestions to the vendors about which CPU to use in order to achieve the VNF performance closer, like maybe 10 gigabit per second or 40 gigabit per second. On the other hand, we can also help vendors to design the software stack or which NFVI to use to achieve the best performance. In short, our lab performs VN or container performance tuning by CPU pinning, NUMA configuration, BIOS configuration, etc. And we use some data plane acceleration technology like SROV, SmartNIC, DPTK, VPP, even Q18 or Intel AES-NI. We can also support different test scenarios like SD-WAN, VN training, etc. Here's a test result for NUMA configuration. While running VNF on a dual CPU socket server, a misconfiguration for NUMA can lead to a 10 to 20% drop in the performance. A VNF SNIC must be in the same NUMA node as its allocated CPU core. And here's another example for obvious DPTK versus SRIOV on L2 forward for different packet sizes. As you can see, performance with SRIOV pass-through is almost similar to that of the bare metal for every packet sizes. However, the performance of obvious DPTK is equivalent to that of the bare metal in large packet scenarios. So, if our vendor's VNF is for the IoT scenario, SRIOV will be a good choice. And if it is for video streaming, maybe obvious DPTK is good enough. Besides the performance lab, our team is also in charge of the NFVI for Taiwan governance 5G project. So, in this part, I will introduce how we built a private edge NFVI solution based on the skill and technology from Performance Lab. As we all know, Kubernetes is the most famous container orchestrator, but there are some still limitations in using Kubernetes with VNF use cases. Firstly, by default, Kubernetes only supports one NIC for a pod. This makes it hard to decouple the control and data plane. Also, the network routing behavior is not that flexible. All the external traffic must go through either a node port on a master or a load balancer. Another challenge is that Kubernetes does not guarantee performance stability. It doesn't care about the NUMA configuration, CPU pinning, etc. So your VNF workload might get swapped from another CPU core from time to time. Also, Kubernetes ignores if we use some performance accelerator like SRLV, SmartNIC on work nodes. We must tell the Kubernetes scheduler which nodes has what resources that required by the VNF. So how do we address these problems? How to provide multiple NIC support for a pod? How to enable CPU pinning and NUMA awareness in Kubernetes? For the network layer, we imply mounted CNI. Mounted CNI allows us to attach multiple network interfaces to a pod, so we can attach multiple SRIOV VF to a single pod for different purposes. For example, one VF is for S1 interface, one is for S11, and another is for internal data network. Moreover, if your SRV or DPDK solution is not fast enough for your VNF, our NFVI can also attach a SmartNIC to your VNF. And we also imply some plugin like CMK for CPU pinning and NUMA awareness in Kubernetes. Here's a real private edge network use case that we have built in a music center in Taipei last year. There's a MEC which runs on our NFVI at the edge side. And for different networks like S1, S11, we provide different SRIOV VF to separate the network traffic. Also, there's a VR edge application that runs on our NFVI too. This VR application creates a virtual room with a big screen showing real-time streaming of the concert. So people can have the best experience even if they are not seated in the front row. And in the network traffic aspect, whenever UE tries to reach the application, it will go through an edge small cell and then the MEC. If the target application is at the local edge, MEC will bypass to the edge application. Otherwise, MEC will send the traffic to the remote EPC. For example, if UE likes to reach some service on the AWS, and MEC will pass the traffic to the remote EPC and then to the cloud. Finally, here's the detailed network architecture for our NFVI and the core network services. You can see we attach several SRV VFs to a pod for different networks. Some of them are for S1, some of them are for S11, etc. Also, there's a P4 SmartNIC for the SP Gateway U GTPU acceleration. You can easily enhance the network performance by changing SRV NIC with SmartNIC for higher network throughput. And all the network functions are containerized and managed by Kubernetes with performance optimization like CPU pinning, NUMA configuration. And this is my sharing. Thank you very much.
Okay, hi everyone. So if you have any questions, you can just ask or type your question in the chat room. Okay, there's a question about any plans to propose change to Kubernetes, so Kubernetes to support our high performance feature. Yeah, actually, since we employ some plugins like CNI plugins or CMK plugins, if we have some, they have still some disadvantage about NUMA configurations or etc. And we will develop our own solutions. If we think it's good enough, and we will commit back to the communities. Yeah. And what? Okay, there's another problem, a question about what ITRI stands for. So it stands for. Wait a second. It stands for Industrial Technology Research Institution. Okay. And I will leave my email, and if you have any questions, you can send a mail to me. Okay, we have another question about asking about, is there container orchestration better than Kubernetes for telecom needs? I think for the container orchestration, the Kubernetes is our only choose. So if you would like to use the open source solution, yeah. But if you would like to use maybe some commercial solution, maybe you can check the OpenShift. I think OpenShift have some co-work with the telecom, and recently Microsoft is have some co-work with the telecom too. Yeah. Okay, so if you have any questions, so you can just email me, and that's it for my session. Thank you, everyone.